Hey folks, welcome back to the channel. In this video, we'll be covering two problems. First is coin combinations 1, and second one will be coin combinations 2. Both of these problems are pretty similar. We'll first check coin combinations 1, and then we'll check what are the similarities and how this problem coin combinations 2 is different from coin combinations 1. Let's tackle this problem first. So you have been given n coins. Each coin has a positive integer value. Your task is to calculate the number of distinct ways you can produce a sum of x using the available coins. Let's consider this example which is given here. You have been given coins of denomination 2, 3, and 5, and the sum which you want to achieve is 9. One way would be to use a 2 rupee coin, then again a 2 rupee coin giving you a sum of 4, and then using 5 to get the sum of 9, that is 4 plus 4. These three are the same, just that the arrangement is different. So here you can clearly see that the order in which you use coin also matters. Similarly, 3 plus 3 plus 3 is 9, and these are some other cases which contribute to the answer. So in total, there are 8 ways. We have to print the number of ways, modulate into the 9 plus 6. Let's look at the logic building part first. So reiterating the question, this is your coins array of size n, and the coins you have here are C1, C2, C3, and so on till Cn. The sum which you want to achieve is this x. Each coin can be used an infinite number of times, as we saw in the example. Order of coin matters. That is, we are considering ordered pairs. Suppose you had to make a sum of 5, then 2 comma 3 and 3 comma 2 will be considered differential. Now building upon the logic which we have so far used for the previous two problems, this problem isn't necessarily any different. If you know how to get x minus ci, you can just add ci to it and you will have the sum x, right? So this basic idea is all you need to solve this problem. The number of ways in which you can obtain the sum x, that is answer of x, will be summation of answer of x minus ci, where I ranges from 1 to n, such that x minus ci is greater than equal to 0. Notice how similar these solutions are to the previous problems which we encountered, that is dice combinations and minimizing coin. And finally, for the base case, if you want to achieve a sum of 0, you don't need any coins, and hence there is one way to do it. So you initialize base case, that is answer of 0 to 1, and that's just it. Let's move on to the code and see how we'll code this. So here's the code. We are doing pretty much the same thing which we did in the earlier problems. We have an array of points Pn and a dp array to store the answer. Initially everything is 0. The number of ways to obtain a sum of 0 is 1. Here we are iterating over the sum which we want to achieve, and inside we are iterating over the coins one by one. If value minus c of I is greater than equal to 0, we are adding the number of ways and then performing the modulo operation. Finally, we are printing the number of ways to the constant, and that's the solution. Now, before submitting the solution of this code, I would like to cover the second problem as well, so that I can cover the differences these two problems have. Let's move on to the second problem now. This is the second problem. As you can see, it's pretty similar to the first problem, coin combination 1, but with a subtle difference. Here, the order of coins doesn't matter. And that's why for the same example of obtaining a sum of 9, there are only 3 ways, which are these, instead of 8 ways which you had here. So you must be wondering that the logic will remain same only. If we know the ways in which we can achieve x minus ci, we can just add ci to it and we'll have calculate the number of ways by summing over. So where does the difference really come? How do we account for orders and so solutions where the order doesn't matter? Well, it's a very nifty way. Only the order of for loop needs to be changed. So I'll show you the code and we'll talk about the differences there. So this is the code for coin combinations one, which you guys saw earlier. Here in the outer loop, we were iterating on the value which we want to obtain. And this is the for loop on which we are iterating on the coin value. So for each value, you are iterating over the coins array from scratch or from the beginning is what I wanted to say. So that way you are accounting for the orders. Because suppose you obtain the sum of three in this style array when value is three. When you come to five, all the coins will be reused again. And hence the order in the solutions will be accounted for. So if you want to only count, say, one solution, it's sufficient to count only the lexicographically smaller solution or the first solution which comes into picture. For that, you just need to swap the order of for loops. So now we are iterating over the coins array in the outer loop and iterate over the values which we want to obtain in the inner loop. And the rest of the code remains exactly the same. Why does this work? I'll explain it once again. So here, since the coins are in the outer loop, you fix an order of a solution, right? And that order will be followed for all values. The order in which the coins are taken as an input is the order which we'll use for forming the solution. So suppose the coins are, let me write this here. Suppose the coins are inputted in the order 2, 3, and 5, or let's make it like this, 3, 2, and 5. The order in which you form, say, a value, something like, say, 7, will always follow this order of 2 being first in the solution, then 5. So this 5 comma 2 solution can never come. Whereas this was possible in the other solution because you were sort of iterating over the coins array over and over again for each value. And hence this is why this will count lesser number of values than the code which is preventing coin combination one. So think about it clearly. Even perform a try run. This is a homework for you guys so that you can understand the problem better. Take one example. Dry run the code for coin combinations one over that input and dry run the same sample input over the code of coin combinations two as well. And then think about how the order is being maintained in coin combinations two and how is it different where we are counting all the ways that is considering ordered pair differently in coin combinations. Now we'll submit both the approaches and see if they get accepted or I'll first submit coin combinations one and it gets accepted. Let's move on to coin combinations two and submit it as well. Let's submit coin combinations two now. Yeah, it gets accepted as well. So think about what we have discussed here today and do dry run the code on same sample input to really understand why this order of for loop changes the solution or changes the number which was printed on the console due to the same code. That way you will really understand how the order of for loop also plays a role and we should not consider it nonchalantly. So thank you for watching, like, share and subscribe and see you next time.